Sanbonani Abafundi, and welcome back. And we are carrying straight on with our study of equations. Just practice, practice, practice. The more we practice, the better we get. Zama zama bese ungobe. Right, let's dive in. So this first one, we're on page 25. As always, if you haven't tried this question yourself already, rather try it first. Don't just watch me doing the maths, all right? If you watch us doing the maths, you're not going to get better at maths. The best way to get better at maths is to practice. Okay, so we've got some choices here, but let's get rid of these brackets first. So 2x plus 6 plus x equals 10 plus 2x. Sorry, 10 plus 2x. Now, as you get more and more proficient, you might be comfortable doing more than one thing at a time. Right. So for example here, you might say to yourself, okay, there's a 2x on both sides, so those can actually subtract. And all we'll be left with here is x. And I don't want this plus 6 here, so I'm going to subtract 6 from both sides and we get x equals 4. Right. Now, I'm not recommending that you do that for now. I wouldn't leave out steps until you are very, very confident. Right. It's a little bit like riding a bicycle. When you're learning, you need to go slowly. All right. When you've mastered it, you can go faster. All right. But so don't leave out steps. But let's just check if this answer is correct. 4 plus 3 is 7. 2 times 7 is 14 plus 4 is 18. The left-hand side comes to 18. Let's check the right-hand side. 2 lots of 4, 2 lots of x is 4, 2 lots of 4 is 8. 8 plus 10 is 18. It's definitely correct. Okay. The next one. This one we will do in full. We won't leave anything out. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Plus 5 equals negative 10. Right, now I mistakenly wrote an equal sign here. Don't write an equal sign there, right? We don't do that. We just have one equal sign on each line. Okay, then let's simplify what we've got on the left-hand side. We've got minus 3x. We've got plus 11 is minus 10. We don't want this positive 11 here. How can we get rid of plus 11? We can subtract 11. That's right. From which side? That's right. From both sides. Minus 10 minus 11 is minus 21. All right. Now, what's happening to x here? X is being multiplied by minus 3. How do we undo multiplying by minus 3? We divide by minus 3. On which side? On both sides. Again, I'm going to write it like that. Okay, and notice that this is 1x. Okay, on the next line, I'm not going to write the 1. We don't need the 1. What happens when we divide a negative number by a negative number? That's right, we get a positive answer. So, final answer, positive 7. Let's check it. If we put 7 into this bracket here for x, we get 5 inside the bracket. Negative 3 times 5 is negative 15. Negative 15 plus 5 is negative 10. And we get negative 10 on both sides. It's definitely correct. I love this maths, all right? I love the fact that we can check it and we know straight away. We don't have to ask our teacher. We don't have to ask our mother or our father or our brother or our sister. We know we are right. Okay. This one's got fractions, okay? Remember, we've got a division by 2. So the way we undo dividing by 2 is we multiply by 2 every single term on both sides. So this x needs to get multiplied by 2. This 3 needs to get multiplied by 2. This 2x needs to get multiplied by 2. Is it better or worse than it was? It's much better. It doesn't have any fractions now. On the on the left-hand side, we've got 5x. If we add the 3x and the 2x, minus 1. And on the right-hand side, we've got 6 plus 4x. Right, we want to get what 1x is. So let's subtract 4x from both sides. Right, if we subtract 4x from both sides, we're left with 1x on this side. And on this side, all we've got is 6. Now, what's the last thing we should do to get rid of a minus 1? How do we get rid of a minus 1? How do we undo subtracting 1? We add 1. That's right. To which side? To both sides. Okay. And we get x equals 7. Let's check that answer. All right. So 3 times 7 is 21, minus 1 is 20, 20 divided by 2 is 10, 10 plus 7 is 17. I'm hoping you're realizing it's really useful to be able to do basic maths well. All right, your normal tables and bonds. On the right hand side, 2 lots of 7 is 14 plus 3 is 17. We get 17 on both sides. X equals 7 is the only number that will do that. Okay, the last one on this page, we're going to take out the bracket first. 2 minus. Now just be careful here. We're going to subtract 2x. You might want to almost think, and I'm going to write it with a red pen here, you might want to almost think as 1 here. So now this negative 1 multiplies with a negative 5 to actually give us positive 5. All right, another way of thinking of this is subtracting negative 5 is the same as adding 5. And we get x plus 16 on the right hand side. It's better than it was. It used to have brackets. It doesn't have brackets anymore. On the next line, let's just collect the like terms that we've got. 2 plus 5 is 7. 7 minus 2x is x plus 16. At this point, we can choose. We can subtract x from both sides, or we could add 2x to both sides. Either way, we will end up with all of our x's on one side, which is what we want. Let's add 2x to both sides. So they're going to disappear from the left-hand side. And on the right-hand side, instead of x, we're now going to have x plus 2x, 3x plus 16. Okay, now we don't want this 16 here. What can we do to our scales to get rid of a positive 16? We can subtract 16 from both sides. Okay, so 3x is 7 minus 16. Okay, I happen to know that 7 minus 16 is minus 9. So 3x is minus 9. Last thing we're going to do is we are going to divide both sides by 3. And when we divide both sides by 3, we get x here, and we get negative 9 divided by positive 3. And remember, that's a negative answer. Okay, 9 divided by 3 is 3, but it's negative 3. Okay, because we're dividing a negative by a positive. Let's test that answer. You notice we're testing every time. We're developing a habit of checking ourselves. 2 lots of negative 3 is negative 6. Negative 6 subtract 5 is negative 11. 2 subtract negative 11 is the same as 2 plus 11. It's actually 13. And on the right hand side, if x is negative 3 plus 16, also 13. This is right. Now we go on to the next question, feeling good about ourselves, feeling confident. We've got this, okay? We've got this. Because when we know we've got this, we are less likely to make mistakes. Okay, so the next one. We're now on page 26. I think maybe many of you have not tried these questions. So I'm going to ask you to pause the video and try them and then let it play again. Okay, so this one over here. We've got choices here. We could subtract 2x from both sides, or we could subtract 5x from both sides. It really doesn't matter. Okay, if we subtract 2x from both sides, it's going to look like this. 2x plus 4 minus 5x. And on this side, we're just going to have 7. We've subtracted the 5x that was there, so it's gone. Okay, now we're going to do two things at once here. Now, I hope you're going to be okay with this. We're going to collect these two like terms. What's 2x minus 5x? It's negative 3x. I'm going to also at the same time subtract 4 from both sides. And when I do that, I get 3. 7 minus 4. Now, what should we do to both sides to get rid of multiplying by minus 3? We should divide by minus 3. So we're going to get positive 3 divided by minus 3. Remember, when we divide a positive by a negative, we get a negative answer. So negative, and 3 divided by 3, just 1. Okay, let's check it. All right, we're checking every single one. When x is negative 1, 2 lots of negative 1 is negative 2 plus 4, positive 2. Positive 2 on the left. And when x is negative 1, 5 lots of -1, -5, plus 7, positive 2. This is definitely correct. Okay, the next one's got some fractions. Don't be scared. What can we multiply everything by so that both fractions disappear? All right, and we're going to multiply by 3 and by 2. All right, and I'm going to do this. Yes, let's do it. So basically, if we multiply by 3 and then we also multiply by 2, that's the same as multiplying by 6. So what we're going to do, we're going to multiply 3 by 6. Now I'm going to write this out. It's going to be x over 3 plus x equals x over 2 plus 5. Okay, and let's see what we're going to do. Every single term is going to be multiplied by 6. Now I'm going to write my 6 as 6 over 1 because it's a fraction. I'm multiplying by a fraction. Here I'm just going to write a 6. Here I'm going to write a 6 over 1. And here I'm just going to write a 6. So 5 times 6. Okay, now watch what happens here. The 6x divided by 3. 6 divided by 3 is actually 2x. So in fact, the 3 divides out and the 2 still multiplies in. Over here we've got 6x. Over here we've got 6x divided by 2. Now 6x divided by 2 is 3x. So we could have divided the 6 by the 2 first, but we get 3x either way. And then 5 times 6, 30. Is this better or worse than when we started? It's much better. And the reason it's much better, there are no fractions now. Okay, on the left-hand side, we've got 8x. On the right-hand side, we've got 3x plus 30. What can we do to both sides to get rid of 3x here? That's right, we can subtract 3x from both sides. Remember the idea of a set of scales. If we subtract 3x from both sides, on the right-hand side, we've just got 30. On the left-hand side, and I hope you're okay with me just writing it down, 8x minus 3x, 5x. Right, now what does 5x mean? It means x times 5. How do we get rid of timesing by 5? That's right, we divide by 5. On which side? On both sides. So our final answer is going to be 30 divided by 5. Hopefully we know that 30 divided by 5 is 6. Okay, we're going to check this answer because there's quite a lot that's been going on here. If x is 6, this becomes 6 divided by 3, which is 2, plus x, 2 plus 6, we get 8 on the left-hand side. On the right-hand side, if x is 6, 6 divided by 2 is 3, 3 plus 5, we get 8 as well. This answer is correct. Okay, all right, if you haven't tried the next two, pause the video and try. Okay, and then we'll let it play again shortly and see how we go. Right, big swig of tea. Okay, let's see. Let's take away the brackets. 2x minus 6 minus x equals x minus 6. Okay, let's collect the like terms on the left-hand side. 2x minus x, just 1x. Minus 6. And on the other side, we've got x minus 6. Now at this stage, we can see we've actually got exactly the same things. This is always going to be true. If you take a number and you subtract x and you get the same answers if you take a number, subtract x, that will be true for any number. Do you agree? If x is 7, both sides will be the same. If x is 12, both sides will be the same. If x is minus 3, both sides will be the same. If we were to subtract x from both sides, we get minus 6 equals minus 6. Now that's always true. So the answer here is true for all values of x. True for all x. Okay. And if you don't believe me, let's just try it. Just make up a number. Come up with a number and test it on the left-hand side. Okay, suppose x is 10. 10 minus 3 is 7. 7 times 2 is 14. Minus 10, we get 4. And if x is 10, on the right-hand side, we get 4. Now that worked for 10. I promise you, you can try any number you like. and you'll get the same answer on each side. Okay, and the very last one that we're going to do, let's take out the brackets here. 3x plus 9 equals 2x plus 8 plus x. Okay, on the left hand side, let's just leave it as it is, and let's collect the terms on the right hand side. We've got 3x plus 9, and here we've got 3x plus 8. Okay, now if we now subtract 3x from both sides, we get 9 equals 8. That's not possible. When that happens, remember, we've got no variables left, and we've got two numbers that are not equal, and we're saying that they're equal. The conclusion that we come to, what we write is, there are no solutions. There are no values of x that make this equation work. Okay, right. So that brings us to the end of our little discussion of equations. We're going to stop there. Next time we're going to look at using these equations to solve some real world problems. Okay, it'll be a lot of fun, and we're looking forward to seeing you then. Have a great day, everyone. Salani kahle.